All right, 3.5 is our last lesson on polynomials, but specifically it's looking at rational functions, okay? So 3 things we're going to learn. First is vertical asymptotes, okay? Remember what a rational function looks like for a second? A rational function is one of those that does the L's, right? The parent function looks like this, and it can get moved left and right, up and down, and there's asymptotes that make it jump over the graph jumps over those asymptotes. So we're going to be looking for the vertical asymptotes. So remember, vertical asymptotes are always going to be x equals some value, C for constant, okay? We're going to look for horizontal ones, which is y value, so y equals some constant. Then I'm going to show you how to find what's called a hole in the graph. All right, so to find the vertical asymptote, it's really easy. What you want to do is factor the denominator completely. So look at example 1. If I factor the denominator, I have x plus 1 and x minus 1. You set each factor in the denominator equal to 0 and solve it for x. Well, if I solve this guy, it's going to come out negative 1. If I solve this guy, it's going to come out positive 1. So that means I have 2 vertical asymptotes. All right? If I only had one factor, then I would have only one. That means in the graph, it's going to jump over twice. There's 2 vertical boundaries. So let's look at example 2. Same thing again. If I factor the bottom, the numerator has nothing to do with the vertical asymptote, so ignore it. So x minus 3, x plus 3. So I have 2 vertical asymptotes, x equals 3, and x equals negative 3. Now, you want to make sure when you answer these that you put an x equals with it. Don't put x equals 3, comma, negative 3, because these are lines, and lines deserve a whole equation. So remember, vertical equations are always x equals something. Now, the second thing we want to find is how do we find the horizontal asymptotes? All right, so here's my little trick for that. When you're determining horizontal asymptotes, what you're looking at is the degree of the numerator. What is that? The highest power of x in the numerator versus the highest power of x in the denominator, okay? And then you follow this little rhyme, Bobbio, Botno, eats DC, okay? And here's what this means. Big on bottom, if the power of x is bigger on the bottom, then your horizontal asymptote is y equals 0. That's what yo means. Yo is yo answer. If it's bigger on top, then there is no horizontal asymptote, none. If it's eats DC, that means exponents are the same, like both x squared over x squared. Then you divide the coefficients. So if you had x squared over 3x squared, you divide the coefficients. It's 1 over 3. Okay? That's what DC, divide the coefficients. So if you just remember Bobbio Botno eats DC, you'll always know your rules. All right, so let's look at number 3 here. We're just going to look at horizontal asymptotes alone right now. So Bobbio Botno eats DC. Look at your highest power of x is x squared on top, x squared on bottom. Huh, they're the same, right? So that's an eats DC. Exponents are the same. So what do? DC. Divide the coefficients. 2 over 1, which is 2. So I have y equals 2. That is my horizontal asymptote. And you'll only have one of these. You won't have more than one if you have one at all. Okay? So look at this one. Look at your power of x. Okay, x is the power of 1 in the numerator, x is the power of 2 in the denominator. So where is it bigger? It's big on bottom, so this is a Bobbio. So big on bottom, y equals 0. All right, this works every time. So let's look at how to find a hole. Now, what's a hole? Well, if you have a graph of a rational function, sometimes the graph will actually skip over a point, something like that. And it's actually called a hole, like a rabbit hole. Okay? And we can find those holes by having like factors in the numerator and the denominator. So what you're going to do to find the hole is you're going to factor numerator and denominator. And then any repeated factors, like if you have the same factor on the top and the bottom, that's a hole. So we'll set that repeated factor equal to 0 and we'll solve it. So on example 5, let's do this. Let's factor this. So this is x plus 2, x minus 1. The denominator is going to factor x plus 2, x minus 3. All right, it's completely factored. Now if I take out that, that's my hole. Okay, so x plus 2 is my hole. That means where x is negative 2, there's a hole right there. All right? Now, from here, the whole is where x is -2. Oops. Now, if I want to do my vertical asymptotes, I do it with whatever's left of the whatever's left of the function, okay? Don't disregard these two because those are gone. So look at the vertical asymptote. What's left in the denominator only, remember? It's where x is equal to 3. And the horizontal asymptote, remember, look at the original equation, go back to the original equation and decide, is it Bobbio, Botno, or each DC? Powers are the same, so it's each DC, so it's just y equals 1, all right? So we'd say, actually, with the whole, we would say the whole at x equals -2, all right? So let's try number 6 here. Start by factoring. So if I factor the top, I get x minus 3, x plus 3, x minus 1, divided by, that will factor to x plus 3, x minus 4. All right, so my whole is where x plus 3 equals 0, so that's where x is -3. So I would say a whole at x equals -3. Vertical asymptote, look at what's left of the function and just look at that denominator. So where x is -4, solve that. I get where x is equal to 4. Horizontal, go back to the original equation and decide, is it Bobbio, Botno, or each DC? Okay, the power is 2 on top, 2 on the bottom. So this is an each DC. So I divide the coefficient. So that's a 1 and a 1 gives me a 1. So it's just y equals 1. All right, there's my answer. Okay, a couple more examples. All right, this one says just do everything like we've been doing. Find vertical and horizontal asymptotes, find any holes. Really, the first thing you want to do when you tackle one of these is factor it, because you need to know if there's a hole, because that changes everything. So I have 3x on top, and I have x minus 3, x plus 1 on the bottom. So there's no common factors, all right? So there's no holes. So I would say holes, none. And then I'm going to do my, so I have 2 factors on the bottom, so I solve each of those, and so I'm going to have 2 asymptotes. I'll have an asymptote where x is equal to +3, and an asymptote where x is equal to -1, all right? Now, for the horizontal, Bobbio, Botno, or each DC, go back to the original equation. This is x to the power of 1. This is x squared. Well, where is it bigger? On bottom. So remember, big on bottom, y equals 0. So yo is your answer. So y equals 0. That's all you got to know. Number 8. Looks like it's already factored for us, so we can look. Is there any holes? No holes. No repeated factors top and bottom. Vertical asymptote. Okay, be careful. You have 2 things here. You have an x squared equals 0. That means x is equal to 0. So you have an asymptote where x is equal to 0 and where x is 3. Horizontal. Okay, look at the power of x. Look, there's no power of x up here, so it's none. So don't stress out about that. Just know that it's bigger on the bottom automatically because there is no x on top. So it's a Bobbio. Yo is your answer. So y equals 0. That is your answer. All right, that's how you handle it. It's really easy. Holes, vertical asymptotes, and horizontal asymptotes.